We are back, and I'm going to show you the screen we're going to work on. Here it is. Please don't copy the molecules, copy only the boxes when we have answers in them. And we're going to start. We're going to do R and S for stereocenters, and I purposefully picked every example where a double switch will be needed. So these aren't straightforward stereocenters. We're going to start with A, stereocenter right here. Heaviest atom is a bromine. That's the 1. Then we have a 3-way tie. You don't have to copy any of this, just watch and get practice. So we have a 3-way tie with carbons. The next question is, what is the heaviest thing on each of those carbons? And the answer is they each have at least one more carbon the same distance. So they are still tied. Go back to the blue carbons, that's the original 3, and ask the same question. What's the heaviest atom on this one that we haven't accounted for yet? It's another carbon. Compared to the next heaviest thing here, which is an H, and compared to the next heaviest thing here, which is also an H, we have a winner. Carbon is heavier. Well, it's really the second carbon I drew, which was this one, is being compared to this and this. So we have a 2. Now for the 3, I'd like to point out you should finish these original ones and still see they're tied. That and that are the next heaviest things, and we finally finished with those 2 blue carbons. We have to move on and ask ourselves which of these purple carbons is a higher priority. And I'm not going to do the whole deal. I think you can see it. They both have a heaviest C attached. And then this one, when you get to the C that's attached, has another C. You cannot say the same thing about this C over here, which goes to an H next. So your 3 is here. And your 4 is here. And when the number 4 is not on a dash, a double switch is a useful technique that gives you the right answer. You don't have to use it. I strongly suggest you do, because the technique is straightforward. You've done all the hard work now. Copy the tetrahedron without moving a single bond. Everything is in the same direction it used to be. Find the number 4 and put it on the dash. 4 is here. It needs to be on this bond. That means you switched it with 2. The 4 is now on a dash, which is a required situation for doing R and S. It's a rule. You can't just say, I don't want to do it. That's a single switch. If you put the 1 and the 3 where they were before, I guarantee you have the wrong answer. We don't like wrong answers. So if you do a second switch, you get back to the right answer. So 1 and 3 must also be switched. 1 is now here. 3 is here. Notice I didn't have to redraw the molecule, just the numbers. And now you've got everything that this has. It's been reoriented using the double switch method, which puts the 4 on a dash. The connection is clockwise now between 1, 2, and 3. Ignore the 4. That's why we put it on the dash, so we can ignore it. 1, 2, and 3 is clockwise. Therefore, it is R, because the clock is moving as it righteously should. Okay, there's our first one. Yeah, this is going to be a lot of work, isn't it? I'm going to go and do the next one. I put BR again. This has got two stereocenters here. A stereocenter I'm calling B, and another stereocenter here I'm calling C, which is a separate problem. So one at a time. So we have a three-way tie once again. And I'm just going to assume that you're practicing, and you finally got to the point where you know that's the 4. It has only one more bond to C. It doesn't have any more than one more bond to C. The other 2 carbons have 2 more bonds to C. When you see a double bond, somebody is currently unmuted, and if you start speaking more, it's going to be... And that's it, yeah. So when you see it drawn like this, replace the double bond with a second bond to C. This is not chemistry. No, that's not a methyl here. It never was. But in terms of R and S, you now have this C bonded twice to C's, same here, okay? Twice to C, twice to C. So they're still tied. A double bond can be thought of as 2 single bonds for the purpose of R and S. I said for the purpose of R and S. Don't do it for anything else. Okay? So which of the purple C's do you like better? Well, this C has one more bond to C, and this C has one more bond to C. I like those the best. They're tied. They got one more bond to C, one more bond to C. This C and this C, you got to remember, this is not a C with 3 H's like this C. It's a C with, it's the same as this C. So you can think of it as H, another C, okay? And the fact is it has another C, and then this one does not. So this one's going to beat this one. And it's hard, this one. That's 2, and that makes this 3. And you're not allowed to connect 1 and 2 and 3. If you do, you have a 50% chance of R or S being right. Until you put the 4 on a dash, you're not guaranteed to get the right answer. So, double switch again. Copy the tetrahedron. Do not move a thing. I put the bonds in their exact spots. Find the 4, which is currently down here, and move it to where the dash is, which is currently here. That means you switched 4 with, I can't get a circle on my 4. You switched 4 with 3. Don't stop. That's a single switch. You must do 2 switches to get back to the original. 1 and 2 are switching. 2's now on top. 1 is here. And it's R again. It's clockwise. I will show you. 1 connects to 2, connects to 3 in a clockwise fashion. I'm going to prove to you what I've said twice now. If you don't put the 4 on a dash and you connect 1, 2, and 3, in this case, you are lucky. You got it right. In this case, connecting 1, 2, and 3 on the original, you are wrong. You are not lucky. You will be lucky half the time. Some of you are okay with that. Personally, if I'm running out of time and I know I left some stereocenters blank, if I'm running out of time and I left some stereocenters blank.
Thank you. Okay.
Okay, I definitely think you want to stop talking. Because that didn't sound like chemistry. I mean, it's okay if you have questions, but I'm going to go back to my original, and I forgot what I was saying because I'm easily distracted. I'm sorry. So we're going to leave it at that. And now we're going over to here, and we have to do all over again for this stereocenter. And I'm going to do 4 for the H. I'm going to do it in a different color. We'll go with, I don't know, maybe blue. 4 for the H. The C with the BR is 1. The C that's a CH3 will be 3. And yes, I'm advancing like I've learned progressively across this screen. Yeah, I'm going too fast for you now. I know I am. This is where you go back and redo these things slowly on your own. And the CH3 is not going to beat a C that has another C. So that's 2. 4 is not on a dash on any of these questions. I'm copying the tetrahedron carefully as I see it. 4 must switch with what in this example? It has to switch with what's on the dash. It's a 1. 4 is now on the dash. That mission is accomplished. And the 1 has to go where the 4 used to be. Nope, that's not where the 4 used to be. This is where the, careful. Yeah. And then the 2 and 3 switch. So 3 is now to the right. 2 is on top. And this is a very righteous day. That's totally accidental. I don't think everything's going to be R when we're done. But everything's been clockwise, everybody. 1, 2, 3 after your double switch is R. Down here we have a question?
Yeah.
Yes, sir.
For B, why 4? It's 4. No,
Why
the
4 is it 4 because we are on B, which is this stereo center, and the 4 ended up being this carbon because it had only 1 more bond to carbon. The other 3 blue carbons, the other 2, sorry, had 2 more bonds to carbon. The second bond to carbon from each of these beats the H that I didn't bother drawing because that was stuff I talked about over here. So I didn't do it again here. So when you have only 1 more bond to C, you're going to lose to a carbon that has 2 more bonds to C. Similarly, a double bond to C is the equivalent of having 2 bonds to C. So it's also going to beat this one.
I see now. Thank you.
You're welcome. And then moving from C to D, 2 stereo centers, D will be this one. And E will be this one. And the C, let's see. Gonna do this D one first. Do you agree that every carbon attached here, this one and this one and this one, those 3 have bonds to H, and this one does not, only bonds to C? What does that make this carbon for this stereo center? Give me a number 1, 2, 3, 4. It has 3 more bonds to C. These do not.
Number 1.
Okay. That's the one. Yeah. So moving to a new color scheme here. For the D stereo center, the 1 is here. And for the same, with the same logic, a C with 2 more bonds to C is going to beat these CH2s. These are both CH2s. Do you agree they're CH2s? And they go to another C. We're going this direction now, remember. I'm sorry, we're going from here outwards. In green, we're doing this stereo center. If I don't put that there, I'm going to forget what I'm talking about. So the CH2 is tied to a CH2. The C here goes to another C there. You got to go away from the stereo center. The C here goes to another C. So we're tied up here. 2 CH2s. We're tied down here with orange because they're still C and they're the same distance away. Which of those orange C's has more bonds to C? This one. This has only one more. That's going to tie one of these. This has another bond to C. This does not. So that makes this CH2 better than this CH2. And we're going to go with a 3 and a 4. Notice I put the numbers on the atoms attached to the stereocenter. I know I made the difference down here, but don't put the difference down here. It's this group compared to this group, compared to this group, compared to this group. And you can't connect 1, 2, and 3 because it's not, 4 is not on a dash. So the 4 must be found and switched with the dash, which is up to here. And that's the 2 it switched with. 2 goes where 4 was. 3 switches with 1. And finally, we get an S stereocenter. It took a week because that's counterclockwise to go 1, 2, 3. Sinister has finally showed its head. That's for D. Good.
I have a question.
Yes.
Could you have switched 4 with 1 in that case instead of 2?
4 with 1. 4 with 1. Doesn't get 4 onto a dash. There's the only dash on this stereocenter. The purpose of the double switch is to first get the 4 on the dash and then switch the other 2, because the rules of UPAC say you can't connect 1, 2, and 3 until the 4 is on a dash. It's a trick that puts the 4 on a dash. Yes, any double switch does get you back to the original stereocenter. That point you made is accurate, but we need to move towards the right answer. And I'll show you something. It's cool since you brought it up. Copy the stereocenter. I'm going with what you said, and you'll feel better after I'm done. Sure, you said switch the 4 with the 1. I'm doing that first. Watch. Now the 1 is here and the 4 is here. Okay, and keep in mind, we got 2 and 3. All right, so I can't do what I wanted to do. Well, now I got to switch the 4 with what's on the dash because you're out of chances. It's still a good example. I have to think my way through this thing. What's on the dash right now if you haven't switched anything? The 2, right? So I have to switch the 4 with the 2. Here's my second switch. You ready? It's the second switch. You agree? I got one switch on the screen already. Now I'm switching the 4 with the 2. That's a 2. That's a 4. And I never moved the 3, did I? But I did 2 switches, didn't I? And you accomplished your goal. You just did it kind of in a backwards way. Kind of cool. My brother did all that stuff when he was in school and they thought he was stupid, but he's not. He's brilliant. He solved things differently than everybody. Okay. Anyway, but now do you realize we got the same answer because we did 2 switches and we put got the 4 onto a dash? That's still S, right? But nobody wants to do it that way because it's not direct. Okay. So we're moving down to our stereocenter here. New problem, new day. We'll go with, I don't know, purple. I know what I like for the 1. Why is this C a 1? Somebody's saying, wait, it has 2 H's on it. None of the others, well, one of the other C's does. What's the heaviest thing on that carbon that I just put a 1 on? Oxygen. What about the other carbons? This one. And it's the same carbon here as we were talking about before. So I'll put a C that's purple with it too. And so we're doing that, this, and where's the 4th group? C, 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 and that's also purple C, right? Do any of the other C's that aren't this one have an atom as heavy as oxygen? Answer, no. That's why this is number 1. The heaviest atom attached is the heaviest atom, period. And then 2, we're comparing this C that has nothing but bonds to C with this C, which has only 1 more bond to C and 2 H's, and this C, which has only 1 more bond to C and 2 H's. The C with nothing but bonds to C is 2. Which of these CH2s is better? Remember, you're going away from the stereocenter. CH2 goes to a C with nothing but bonds to C. CH2 goes to a C with only one bond to C. I like the CH2 that goes to a C with nothing but bonds to C better. It's 3. It was 3 in both stereocenters. It's a common carbon between both, right? Here's your 4 down here in purple. This red arrow is nothing but confusing now. It's got to go. It's just pointing to the stereocenter I'm doing. Okay, answer is going to be in purple, but it's not going to be until I do a double switch. Oh, I need my purple. That's the stereocenter. Copy. Find the 4, switch it with whatever's on the dash, in this case, the 1. Switch the other 2. 3 is now left and 2's on top. Sinister again. Counterclockwise. You want to see it? Here it is. 1, 2, 3, counterclockwise. All right. Well, by the way, this activity is taking a while, right? So it's a double activity. It's going to be 2 points. We have 2 stereocenters here. This is called a Fisher projection. We have to know that when it's drawn like this with a cross, it's not a Catholic thing. It's a Fisher projection thing. And every horizontal bond is a wedge. So I'm going to redraw that molecule here. Horizontal bonds are wedges. Mr. Fisher helped us so we don't have to always draw wedges and dashes. He was one of the early discoverers of stereochemistry. Wow. And that's an OH over here and an H here. And what do we got? An OH on the left here, H here. And vertical bonds are dashes. This was a dash. This is also a dash. And on top you have a CHO. If you don't draw a CHO, you won't know the C has 2 bonds to O. That's going to beat a C that has 1 bond to O. Oh, yeah, that's the bottom C. And down here we have a CH2OH, which you can just write CH2OH. 2 stereocenters, 2 separate problems. And I'm going to teach you a nice trick. Occasionally, you don't have to do a double switch, even when the number 4 is not on a dash. Yeah. I'm just going to demonstrate something real fast. I got to unshare the screen, if I can remember how to do that. Oh, it's over here. Sorry. New share. Am I not sharing? Pause share. Okay. Are you seeing just me now? Can somebody say yes or no? Just me? Yes or no? Are you seeing? It's got the screen still?
Yes.
Yeah, still a
Okay.
screen.
So we could just
I don't
click
know
on
why
you.
I have a 2 share option here. I got 2 share. Oh my goodness. I think I just created a monster. Go away. Okay. Stop share. Is it just me now?
Yeah.
Good. All right. Now, if I'm doing this right now, move a little over here. What's that look like to you? Clockwise or counterclockwise?
Counterclockwise.
You are 100% correct. But why, to me, is it clockwise? Because I'm still doing the same thing here. Now you see what I saw. Can you see my hand? I can't. I'm terrible with cameras and stuff. I'm still going the same way I was before. Can you see it's clockwise now?
Yes.
Yeah, and you said it was S before. All I'm trying to say is, to me, this is clockwise because the number 4 group's where you guys are, behind the screen. Okay? So the right answers are, because you guys, I got the number 4 back there, and it's wrong for you because the number 4, if it's sticking to you guys, when you're looking at me, it's a wedge sticking at you. Okay? So when the 4 is on a wedge, it's 180 degrees from where it's supposed to be, right? Isn't a wedge 180 degrees from a dash? It is, isn't it? Well, that just means connect 1, 2, and 3, and you have the wrong answer. When there's only 2 answers and you know the wrong one, that's just as good as knowing the right one. So I'll share the screen again and try to show you what I mean in terms of doing the activity. Here we are. So I'm gonna do my 1, 2, 3, 4 here for this top stereo center, which is the F. F is the top one, G is the bottom one, okay? We'll do well, I guess we should do the top one on top. But I want the wedges and dashes. Sorry, I'm talking to myself here. I'm gonna do G first. And I'm gonna do it on the bottom because it's the bottom stereo center. There. Do you agree that the heaviest atom on this carbon is this oxygen? I sure hope you do, because it is. And we got orange doing the bottom stereo center. Do you agree the lightest atom is hydrogen? I sure hope you agree. Now, when we go up here, a C ties a C. I think you know which C wins. There's a tie with the oxygen. Go back to the blue C, the baby blue C. After you've got a tie to oxygen here and here, what's the next heaviest atom attached to this C? This C. What's the next heaviest atom attached to this C? You've already done the oxygen, you can't do it again. And H. C beats H. We have a 2 here, and we have a 3 here, and the wrong answer, you're not just going to believe me on this, I'm going to prove it. The wrong answer is R, because that's clockwise. Why is it wrong? Because your number 4 group's on a wedge and not a dash. This is the only time you can do this. R is wrong. What's the right answer? Ladies and gentlemen, please tell me the right answer.
S.
Thank you. S is the right answer. Okay, I'm going to prove it. Hey, here's your proof. Double switch is needed to absolutely prove it, right? Here we go. Bottom stereo center. You even have 2 dashes to choose from. I'm going to switch the 4 with a 3 because it's on a dash. You could have switched it with those 2 as well. Don't do as well. As an alternate is what I should have said. 4 is now on a dash. That's a 3, the worst 3 ever. And then 1 and 2 have to switch. It's S. You did the double switch, you know for sure now it's S. But you wasted your time because you learned a trick. You don't have to do the double switch if the 4 is on a wedge. Let's see if you got that straight when we go back to the top stereo center. Top stereo center. Please remember this is an aldehyde, which is really C-double-O with an H. That's 2 bonds to O. That's going to beat a C with 1 bond to O. But the most important thing is the O itself here is number 1. The C with 2 bonds to O is going to beat the C with 1 bond to O. That's a 3. And 4, of course, is the H. If you connect 1, 2, and 3, you get the wrong answer. How do I know it's wrong? Because the number 4 is on what kind of a bond when it's horizontal? Wedge. If you connect 1 and 2 and 3 and the 4 is on a wedge, the answer is wrong. S is wrong. Therefore, the answer is R. Okay. Good stuff. And moving on. Once again, you're only copying the boxes. It's hard to find the boxes now. He wrote so much stuff. This is the hardest RNS. I strongly suggest if you are forced to do RNS on this is called a Newman projection. I suggest you don't do it. It's too much work for the amount of points. Too much. But I got to satisfy even the gifted students' thirst for knowledge. So what I'm going to do is I'm going to take my perspective and look at this thing differently. Because I don't know what's a wedge or a dash here, but I will know if I use, wow. This is a lame attempt at an eyeball looking this way. So let's talk about this eyeball looking this way. A Newman has this ball in the front, and behind the ball is a hidden carbon. I can tell you the three things attached to the hidden carbon are a chloromethyl, a carboxylic acid, and a ketone. There is a carbon behind this ball that's also a ball, but you can't see it. So when I put my eyeball over there and this ball here is in front and the other ball is behind, which hand do I have to use to grab the ball that's in front if I'm standing over here? Is it my left hand or my right hand? You're looking right between the balls. Which ball is to the left, the front carbon or the back? I'll await an answer. Say it again.
The front.
Which ball, the front, this ball here, the front carbon, is it to the left of this guy's eye or to the right? I need to hear right, left or right. That's all I want to hear.
The left.
The left. If my eye was over here, the big ball would be to the right. So I'm here. There's other videos where you actually see me physically getting near this computer screen to do what I just said. If you're having trouble visualizing it, because I can't do it here. You saw me have trouble turning around for the screen before. Okay, so remember, CF3 is to your, the ball, sorry, is to your left. Got it. So there's the ball. The other carbon, the hidden one, is the right. Describe this bond. Isn't it straight up? It is. So off the left carbon, because you told me this ball is the left carbon, straight up OH. Off the back carbon, this is straight down, isn't it? Draw that. Straight down. And now you got to use your imagination. Not really. On the front carbon, is the CF3 pointing towards you or away from you? I mean, guys, it's right beside the eyeball. It's got to be towards it, right? It's towards you. We have a way of drawing bonds that are towards us. Wedge or dash, tell me.
Wedge.
Wedge. Is it a little above your eye or a little below your eye?
Above.
Guys, it's down here. The eye's here. It's below your eye on a wedge. Okay? Below your eye on a wedge. There's the CF3. Talk to me about the H. It's definitely away from your eye and below your eye. You can't disagree. How do you draw bonds that are away from you?
Wedge.
Dash.
No, towards you is a wedge. So bonds away from you behind the page, which is where that H is. If you move your eyeball there, that's away from the page and it's below your eye. Going to the other carbon, which one is towards your eye, the CO2H or the chloromethyl? Guys, it's right on top of your eye. It's got to be towards the eye, right there. Is it a little above your eye or a little below your eye?
Above.
Wedge above my eye. Remember, your eye is going along the bond here. That's why you couldn't see this carbon. So wedge above my eye, CO2H. I told you it's a lot of work. What about the chloromethyl? It's definitely away from your eye. And it's above your eye. So either a little above there or a little above here. I can make that one look a little neater. That's why I picked that one. Notice that I'm going to make sure you know there's a carbon right there. Right? CH2Cl. I didn't change it. I know I drew it stick figure. You're finally ready to do the stereocenters. We haven't even, this is just restating the question for crying out loud. I gotta finish this video. It's taking forever, as they say. Are we okay with that being the one because it's an O? And are we okay with a carbon that has a fluorine beating a carbon that has just carbons beating an H? Are we okay?
Yes.
So I was lucky. I chose my eyeball to go there on purpose. So the 4 was already on a dash. This is a straight connection, isn't it? 4 is already on a dash. 1, 2, 3 is that clockwise or counterclockwise? Counter. H, that's H is the front. And this one will be I. And that was counter, which is S. Other stereo center, not so lucky on switch and double switch and go green. Didn't say that. Carbon with chlorine. Beats carbon with, careful, watch this. Every other carbon has bonds to oxygen. How many bonds does a CO2H have to oxygen? I want a number between 1 and 4.
1.
I don't like 1, I don't like 2. That carbon has 3 bonds to O. I redrew it up there. 3 bonds to O beats 2 bonds to O beats 1 bond to O. Don't even talk to me about fluorine. We found a difference before you got that far. Do not talk to me about fluorine there. We broke the tie before we got to the fluorine. Okay. Double switch necessary. How do I know that? I'm going to restate. Yeah, 4 is not on a dash, but we also found out if 4 is on a wedge, that's just as good, right? So 4 is not on a wedge or a dash. I got to do a double switch. That's the translation. Copy the stereo center, wedge dash, and 4 has to go where 1 is to get it on the dash. 1's there now. And 3 has to switch with 2 or else we'll get the wrong answer. 3's top right, 2's bottom. This is as another sinister. Sinister's made a comeback at the end. Okay, that was a lot. All right, so we have 2 copies of this. I just need the boxes A, B, C, D, E, F, G, H, I. Get that onto a piece of, I'm sorry, this is lagging and it's not keeping up and I'm getting annoyed. Okay, I'm leaving it here. I'm not touching it anymore. So we had A, B, C, D, E, F, G, H, I. I need answers for each, just the R's and S's, please. Get that onto a piece of paper, take a picture. Or if you're doing it right on a computer, that's fine. You're doing it by hand. It's got your writing on it. Save it. Submit it to the activity 1 area, which I'm going to change the due date on because we ran longer. So I know you're ready to do it now, some of you. Wait 2 minutes after I finish this video. I will have the due dates changed to 11:55 as the due time, and you'll have a 5-minute grace period. We'll be back at noon. Am I clear? So I'm gonna change the due date to 11:55. And you will have until then to submit it, but if you take a little longer, you have till noon, but the video is going to start at noon. And do we still have a question? I heard somebody start with a question.
Yeah, Professor. I wrote everything down and highlighted the E's and R's. Is that okay?
That's
or should I
fine.
rewrite?
Extra is fine. No, please do not rewrite. You've got everything you need and extra. I just need the letters really. So we're coming back soon. And ending.